This is symbol for the battery.
Yeah, I got that.
Then we have resistor. This is the symbol for resistor. Then we have lamp.
Yeah.
This is lamp. Then we have ammeter.
Yeah.
Okay, this is a symbol for ammeter. Then we have switch.
Yeah.
This is the circuit. Okay.
Yeah, but I didn't lay it out exactly like you did.
Okay, then you should send me the photo if you have any confusion.
Okay, yeah, 1 second. Okay, I sent it.
Yes, it's right.
Oh, okay, thank you.
You have not made switch here, but here it's okay because you just have to make it in series and like next to the battery. So
yeah,
it's okay.
Okay.
Next is this. Read the question.
When the switch is closed, there is a current in the circuit. State the name of the particles flowing in the metal wire. The current is the 15 ohms resistor.
Just answer this.
Okay. Is it electrons?
Very good, electrons. Read next question, part C.
The current in the 15 ohms resistor in figure 8.1 is 0.40 amps when the switch is closed. Calculate the potential difference across the 15 ohms resistor. So it's V equals IR. So you do 15 times 0.4, which is times 0.4, which is 6.
Very good, 6.0 volts.
Yeah.
Okay.
Yeah.
Next.
Figure 9.1 shows a transformer used on a building site. The mains plug for the transformer contains a fuse. Give a reason why the plug includes a fuse and explain how a fuse works. The fuse, it adds safety.
Yes.
And then,
How do a fuse add safety?
Because when there's something wrong with the circuit, the fuse melts. So it allows what?
Why does a fuse melt?
Because of too much current.
Very good. When the current exceeds operating current value, then the fuse will melt and it will protect you and your device.
Yeah.
Okay, should we move on?
Yeah.
Question part B.
The mains input primary potential difference.
You have not done this one. Okay.
Oh, okay.
Next question.
A student uses the circuit in figure 8.1 to find the resistance of a piece of iron wire. Complete figure 8.2 to show the circuit diagram for the arrangement shown in figure 8.1. The piece of iron wire is shown as a thicker line between the points A and B. Okay.
So you have to complete this figure 8.2, using this.
Oh, okay.
This is battery?
Yeah.
Ammeter,
Yeah.
iron wire,
Okay.
voltmeter,
Yeah.
variable resistor. So what is missing? Battery,
Yeah. The voltmeter,
battery, then
ammeter,
voltmeter.
meter,
These are
the
missing. Okay.
yeah.
So ammeter,
Yeah.
voltmeter in parallel.
Yeah.
So is this complete now?
No, we need to have the iron wire.
Iron wire is already drawn.
Oh, okay.
The piece of iron wire is shown
Okay.
as the thicker line between points here. See? Okay.
Okay.
So you see the circuit
Yeah.
and you see this one.
Yeah.
Now it's complete.
Yeah.
Okay, part B.
Okay. The reading on the voltmeter is 1.56 volts. The reading on the ammeter is 0.112 amps. Calculate the resistance of the iron wire, including the unit in your answer. Include the unit in your answer. So it's V equals V equals I times R. So since it's since you have to find out the current, you do V divided by I. Oh no, since you have to find out the resistance, you do V divided by I, which is 1.56 divided by 0. How many decimal point places do I do it till?
You have to see the significant figures.
So
3 significant figures and 3. So our answer should be in 3 significant figures.
13.9.
13. And the unit is?
Wait, the unit is, it's resistance. The unit is ohms.
Very good. Next question.
Okay, figure 9.1 shows a hazardous scenario of using electricity in a kitchen. Identify 3 electricity hazards in figure 9.1. There's water.
Yes.
And there's too many plugs in the socket.
Very good.
The wires maybe. Oh, what's that? The insulation on the wire is damaged.
Very good. Damped conditions, which means water.
Yeah.
Damaged insulation.
Yeah.
And too many appliances connecting from single socket.
Yeah. Okay.
Okay, then.
Give 2 possible consequences of the electrical hazards in figure 9.1. You can get electrocuted and appliance can be caught on fire. It can cause fire.
Yes, why? Because of too many appliances connected from the single socket may lead up to higher current from the socket.
Yeah.
Cables will overheat.
Yeah.
Insulation may damage.
Yeah.
It may cause spark, right?
Yeah. Okay. Figure 9.2 shows a circuit for a hairdryer. State the name of the component labeled Q in figure 9.2. Wait, where's Q? Oh, there's Q. Is that switch? No, that's not switch.
Power supply.
Oh, power supply. Okay.
This is the symbol for AC supply I told you, right? And that
Yeah.
difference between DC and AC.
What was that again?
This symbol is for direct current supply, DC supply. Okay.
Yeah.
Both are current supply, both are power supply, but one is DC and the other one is AC.
Okay.
This symbol is for AC supply, alternating current supply.
Oh, okay.
And that one was for direct current DC. So you
Okay.
should know AC and DC. We have done this in chapter 4 of electricity.
Okay.
Practical electricity, okay?
Okay.
Part 2.
On figure 9.2 in the dashed box F, draw the circuit symbol for a fuse. Is it, wait. The fuse symbol is, I can't remember. Is it just like a box and then a line through it?
Very good.
Yeah.
Yes.
Yeah.
Okay.
And then, okay. Yeah.
A line in a box. If you do not draw the line, then this is for resistor.
Okay.
State the purpose of fuse.
It's to provide safety.
In case if the current exceeds the operating current value, right?
Yeah.
Okay. And state an advantage of using circuit breaker instead of fuse.
I mean, every time there's more current, the fuse melts, but in the circuit breaker you don't need to and then you have to change the fuse, but in a circuit breaker you don't need to change it.
Very good. Circuit breakers need not to be replaced.
Yeah. A different hairdryer has a fuse and 2 heat settings. When the hairdryer is used on the low heat setting, the current in the hairdryer is 5.2 amps. When the hairdryer is used on the high heat setting, the current in the hairdryer is 8.9 amps. Circle one correct fuse rating for this hairdryer. What does this question mean?
Read the question again.
Okay. A different hairdryer has a fuse and 2 heat settings. When the hairdryer is used on the low heat setting, the current in the hairdryer is 5.2 amps. When the hairdryer is used on the high heat setting, the current in the hairdryer is 8.9 amps. Circle one correct fuse rating for this hairdryer. What does it mean by fuse rating?
Like if you have appliance of 8 ampere, right?
Yeah.
The fuse you will use will be of 9 ampere.
Yeah.
The rating means how much, what will be the value of the fuse.
Okay, would it be 15 amps?
Oh, it should be like slightly greater than 8.9.
Oh, so 10?
Yeah.
Oh, I added them both. I'm like, oh, okay.
This is the minimum current it requires. This is the maximum current it requires. So the appliance does not need more than 9 ampere, right?
Yeah.
So we have to add a fuse of greater than 9 ampere, slightly greater than 9 ampere, so that if current exceeds the operating current value, fuse melts and switches off the appliance because it is unusual for the appliance to have greater than 9 ampere current, right? So this will be in case of fault only. So the fuse, because it is of 10 ampere, it will melt, indicating that there is current greater than the operating current which is required for the appliance to work normally.
Okay. The unit of the two electrical quantities, electromotive force and potential difference, is the volt. State one other similarity between EMF and potential difference. I remember this one. Wait. Do they both use power? No. No. That's wrong. Yeah. What? Oh yeah.
And what about next? State one difference.
Um. Is the no. I forgot. Wait.
EMF is for one complete circuit, right?
Yeah. Oh,
There is one more difference. EMF is the energy change from chemical to electrical, while potential difference is energy change from electrical to any other forms of energy.
okay.
So you can just go through the definitions of EMF and potential difference and just see the difference, okay?
Okay.
Part C.
A battery consists of 4 cells, each of EMF of 1.2 V in series. Calculate the EMF of the battery. In series, so isn't the voltage the same?
No,
So
you have to add 1.2 times 4.
you told me the voltage in series always stays the same, or is that current?
In parallel is the same.
Yeah, parallel. Oops.
And you are actually mixing the two understandings. We are talking about cells in series, not the series circuit or parallel circuit, okay? So these are two different topics.
Okay.
You have to memorize these as well. You have to go through the two topics, cells in series, cells in parallel, okay? And then circuits in series, circuit in parallel.
What's the difference? I don't understand.
Let me tell you. In this, you can see the cells are connected in
Yeah.
series, right?
Mm.
And this circuit is a series circuit.
Yeah.
If, for example, in this circuit, the cells the cells are connected in series, right?
Mhm.
And the circuit is also series,
Yeah.
but I can make the circuit parallel circuit. For example, if I add a resistor here, the circuit will be a parallel circuit, right?
Yeah.
But the cells are still in series. So these are two different understandings, whether the circuit is in series or parallel, and whether the cells are in series or parallel.
Okay. What does it mean if it's in series? So the battery is in another junction?
When you are actually saying that the cells are in series, you are actually saying that these cells are adding up to make a battery. For example, if these are two 5-volt cells, you have a 10-volt battery.
Yeah.
But if you have two 5-volt cells in parallel, this is still a 5-volt battery.
Okay.
Okay, so since it's written the cells are connected in series, so each is of 1.2. So 1.2 times 4 is 4.8.
Okay. The battery is connected in a circuit with four 12 ohms resistors. Figure 8.1 is a circuit diagram. Calculate the total resistance of this arrangement of resistors. Are they all in parallel?
No, this is combination series and parallel.
Oh. So, okay. So the 12 ohm, it would be 12 plus 1 upon 12. Wait. So the two ones that like paired in one junction, would I just add both of them as 12 plus 12 and then do like 1 upon 24? Right? Or would I do 1 upon 12? Yeah?
This is 12 and
Yeah.
12.
Yeah.
Okay. If the 12 and 12 are in series, it will become 24, right?
Yeah.
24 and then this 12 are in parallel.
So 1 upon 24 plus 1 upon 12.
Yeah.
Okay. And then you add that with 12. So I got 12.125, but then you have to flip. So I got 97 over 8, and then you flip the fraction, no? Oh, no, you flipped it. Oh, wait, I confused myself.
1 upon 24 plus 1 upon 12 is 1 upon 8, right?
Yeah, then so it's 8 plus
Yeah.
12.
8 plus 12.
So 20.
Yeah. Okay.
Yeah.
Calculate the reading on the voltmeter in figure 8.1. These are the same cells, okay? 1.2 volt cells in series. So how much is the voltage?
How'd you do? Oh, okay. Resistance. So V equals IR. Oh, is it just 4.8?
No, 4.8 is the voltage of the whole circuit, right?
Yeah.
You have to find out the voltmeter reading, which means you have to find out the voltage across this resistor.
Okay, so you divide by 12. Or times it.
Divide by what?
12?
No.
Why? But the resistance for resistor 4 is 12.
You can use proportionality method, okay? Let me tell you this trick. 4.8 volts is actually for 20 ohm resistors, right?
Yeah.
For the complete circuit, okay?
Okay.
But you have to find out just for
4.
this one, which is 12.
Okay.
So I can say 4.8 volts is across 20 ohms resistor, right?
Yeah.
And you have to find out the voltage across 12 ohms only.
Yeah.
So just cross multiply.
Times 4.8. Is it 8?
Yeah, so answer is not 8, 2.8 volts.
Why?
12 times 4.8 is what?
But don't you do 20? So you do 20 divided by 12, and then what answer you get you times by 4.8.
No, cross multiply.
Okay. That's
12 times.
I got 57.6.
You cannot get an answer which is greater than 4.8 because you know 4.8 for the complete circuit, right? So
Yeah.
it's obvious that your answer should be less than 4.8.
So when I did 12 times 4.8, it gave me 57.6.
Just do 12 times 4.8.
Yeah, I did that. I got 57.6.
Divided by 20.
Oh. 2.88.
So this is your answer, 2.8 volts, okay?
Wouldn't it be 2.9?
You've got 2.88.
Yeah.
And can you do this 4.8 divided by 20?
0.24.
Times 12.
2.88.
Okay, so answer is 2.88, 2.9.
Okay. Yeah. Wait, so I don't understand. So you do I equals VR, and then you do 4.8. Where did you get the 20? The 20 is the total ohms resistor. And then you do that 0.
I have done two methods, okay? One method is this one, and the other one is this.
Okay.
So it's your choice which one you select.
But in the first one, like, I don't understand why we divided by 4.8. That if you're supposed to cross multiply, why did you divide it by 4.8?
Where in this part,
Yeah.
I have not divided it by 4.8, divided by 20, not 4.8.
Oh, yeah, why did you divide it by 20?
Because if you cross multiply, you have an equation 12 times 4.8 is equal to 20 times x.
Mm-hmm.
So you find out x.
Oh, okay.
This is called cross multiplication. When two quantities are directly proportional to each other, you can just cross multiply.
Okay, and I can do that in all cases? Like if
In
it's
all cases.
okay.
Yeah. You can also do this in maths, like when you are, for example, if you know that the cost of, for example, 5 apples is $10, for example, okay? What is the cost of 2 apples? So you can just cross multiply.
Yeah. Okay.
5 apples cost $10. 2 apples cost X.
But I do it like 5 divided by 2, 2.5, then I do 10 divided by 2.5. That's 4.
So answer is 4, yeah.
So if I do it in my method, like I do 20 divided by 12, which is 1. Yeah, and then I do 4.8 divided by. I didn't get the same ones. What? 4.
You do like this cross.
Okay, because like I always do it by like, so I do 5 divided by 2, and then whatever answer that is, I do 10 divided by that answer.
I don't know whether, because I've whenever I have done this method, I just do like the cross one.
Oh, okay.
And I would recommend you to do the same, and you make this equation all the time.
Yeah,
And then you find out the answer.
I understand the equation.
Okay, so let us do one more question.
Okay. Oh, I got the answer from my method. Okay.
Yeah.
Oh yeah. Okay.
It's 2.9.
Yeah, I got 2.9.
So I think both will work.
Yeah. The light intensity at the circuit increases from dark to bright. State any effect on the resistance of component Y. Oh, the resistance increases at night. In the dark.
Yeah. What about the light intensity at the circuit increases from dark to bright? Bright means more light.
Yeah. Oh.
More light means less resistance.
Yeah, more light means less resistance.
So state any effect. So you will say resistance would.
Decrease.
And if the resistance decreases, what will happen to the voltage?
It increases.
No, it decreases.
What?
Resistance and voltage are proportional to each other.
Oh, okay.
Less resistance means less voltage.
Okay.
Because you know V is equal to IR, right?
Yeah.
So V and R are directly proportional to each other.
Okay.
Less resistance, less voltage.
Okay.
So the circuit component that has less resistance will have lesser voltage.
Okay. And then it's more current, right?
Current of the circuit will increase, yes.
Yeah, okay. The circuit shown in figure 8.2 is switched on for 2 minutes. The current in the 4.0 amps resistor is 3.0 ohms resistor is 3.0 amps, and the magnitude of the charge on an electron is 1.6 times 10 to the power of negative 19. Calculate the number of electrons that pass through the resistor each second.
Yeah.
For 2 minutes. Is this like the W? Wait. I can't find it.
Q equals to NE. This
Yeah.
is the formula that we studied in
Yeah.
chapter 1, static electricity. Now I is equal to Q upon T, right? Current is charge upon time. And you can replace Q by NE. So you will have NE upon T for current.
Okay.
So you have to find out N. N will be equal to IT upon E.
What?
Make N subject.
Yeah.
IT upon E will be N.
Okay.
I is Q upon T, right?
Yeah.
And Q is NE.
Yeah.
So we have replaced Q by NE, right?
Yeah.
So equation is I is equal to NE upon T.
Yeah. So
Now you want N.
I don't understand why E would go on the bottom.
Make n subject. T will be multiplied by I.
Yeah.
E is the denominator then.
Why is E the denominator? Shouldn't IT be the denominator?
No, the equation is I equals to n E upon T. Okay.
Yeah.
Keep n on one side. Okay. T is the denominator. That's why it will become the numerator when you will shift T to the left side.
Oh, okay. Yeah.
And I is numerator. Sorry, E is numerator. Okay. So it will become the denominator.
Yeah.
So the equation will become n is equal to.
IT over E.
So how much is I?
I is 3.
How much is T?
Do I convert it into seconds?
Yes.
So 120. Huh?
Yes.
Oh, okay. And then
So at an 8 second. Okay. So you have like time is 1.
yeah. And then is E
Value of E.
is 1
Yeah.
point times 10 to the power of negative 19. So that is 3 times 120 divided by 1.6. I got different from what you got. I got 2.25 times 10 to the power of minus 17.
Are you using scientific calculator?
Yeah.
Are you using the fraction button?
Yeah, you did 3 times 1 instead of 3 times 120.
3 times 1 is no, not 3 times 120. Why? Because you are not calculating for 2 minutes. You are calculating for 1 second. It's written each second.
So you just but the current is going on like through 2 minutes. So wouldn't you need to do a bit of like conversions?
Yeah, so we are not calculating number of electrons that have passed in 2 minutes. We are just finding out for 1 minute. So you will divide your answer by 120. So you do not need to multiply it by 120.
So then what was the point of working that out? I don't understand.
Then you have to find out number of electrons that are passing each second. So you have to take time as 1 second.
Oh, okay. So was it like that time, the 2 minutes thing? Is that just
It's for the next part.
Oh, okay.
So you should not use all the information for like a single part because if the question is structured, it may have the data for different parts as well.
Okay.
So calculate the power. The formula for power is
P equals
I square R.
So P equals I squared, that's 3 times 36.
Yes.
Okay.
Okay, now they have not used this information. But
Yeah.
I can, for example, give you a question which is for this information. Let's say if I say find out the energy used in 2 minutes. Okay, so you have to use like energy is equal to power times time. You will take 36 and the time is 2 minutes.
Is it 4,320?
Okay, so they have given you this information just to
Yeah.
confuse, right?